All right, so we are diving into Venus this time. And wow, you weren't kidding when you said you'd been digging into this.
Huh. Yeah, I've been on a bit of a Venus kick lately.
Well, you sent over enough Wikipedia to tell me you're ready to get into it.
Absolutely. Yeah, I'm ready to go deep.
Okay, so Venus, Earth's twin, right?
That's what they say, but, um, maybe not so fast.
Yeah, right? Like size-wise. Okay, I see it.
It's true, there are some similarities in size, but that's about where it ends.
Exactly. I don't think we'd be trading places anytime soon, even if we could.
No, not a chance. Not unless you've got a thing for extreme heat and sulfuric acid rain.
Oh, yeah, pass on that. So, before we get to all the good stuff, all the juicy mysteries like what happened on Venus and all that, maybe we should start with what we know for sure.
Yeah, good idea. Let's lay down some groundwork.
Exactly. So, for the uninitiated, what are we talking about when we talk about Venus?
Well, for starters, it's the second planet from the sun, right next door to us, cosmically
Our
speaking.
next door neighbor.
That's it.
Mm.
And it's always been pretty hard to miss, even in ancient times, because it's incredibly bright in the sky.
It's true. It's really noticeable.
Oh, yeah. You can often see it at dawn and dusk,
Yeah.
which is why it got those poetic nicknames, the morning star and the evening star.
Right. Those names always make it sound so peaceful and serene. Not exactly what I picture with all we know now.
Haha. Well, back then, they had no idea they were looking at a planet.
It's wild to think how much our understanding has changed, especially once we realize just how extreme Venus actually is.
Talk about a reality check, right? It turned out those shimmering clouds weren't hinting at a lush tropical paradise after all.
Yeah, not quite the vacation spot we might have imagined. I mean, a surface hot enough to melt lead? No, thank you.
Yeah, it's definitely not for the faint of heart. And then there's that dense atmosphere. It would feel like being crushed under a huge weight of air.
Like being deep underwater, but without the, refreshing water part.
Exactly. And yeah, did I mention the sulfuric acid rain? Just to add a little zest.
Right, because scorching temperatures and crushing pressure weren't enough. It's amazing to think that at some point astronomers might have actually imagined a more Earth-like Venus, maybe even with life.
It's true. It's easy to forget how much our assumptions about other planets have evolved over time.
Yeah, before we really knew any better, Venus seemed like it could have been a twin, maybe even with some kind of lush alien jungle.
It's a tantalizing thought, isn't it? And the funny thing is, it might not be as far-fetched as it sounds. We've actually found some intriguing clues suggesting that Venus might not have always been this infernal wasteland.
Wait, really? You're saying that billions of years ago, Venus might have been pleasant?
Okay, pleasant might be pushing it, but more Earth-like,
Hmm.
potentially. See, one of the big clues we have comes from studying the ratio of heavy water to regular water in Venus's atmosphere.
Okay, so heavy water. Now you're testing my high school chemistry knowledge here, for those of us who need a refresher. What exactly are we talking about, and how does it tie into this whole ancient Venus idea?
So think of heavy water like this. It's basically water, but with a slight twist. Instead of your regular hydrogen atoms, it's got these heavier isotopes called deuterium.
Okay, so a slightly burkier version of water. Got it.
Exactly. And the thing about heavy water is that it's a bit of a homebody compared to regular water. It's less likely to just escape out into space.
So if we're finding more heavy water on Venus, that means what? Spilled the tea.
Well, it suggests that a long, long time ago, Venus had a lot more regular water hanging around. And when I say a lot, I mean potentially enough to form entire oceans.
Yeah.
Billions of years ago, of course.
Wow. Okay, so we've got ancient oceans on Venus. This is big. But if Venus was once a water world, what in the cosmos happened to turn it into the inferno it is today?
Okay, ancient oceans on Venus, got it. But we're looking at, well, let's just say not an ocean paradise right now. So what happened? How do you go from water world to, well, this? It's quite the transformation, isn't it?
Yeah.
And to understand that, we really need to talk about the runaway greenhouse effect. Basically, Venus got a planetary fever. And I'm talking about a really, really bad one.
Okay, a planetary fever, that's a new one. Walk me through this. How does a planet even get a fever like that?
Well, it all starts with the sun, right? Solar radiation, that's the energy the sun's pumping out all the time.
Yeah.
Now imagine that energy steadily increasing, or maybe get a bunch of volcanoes erupting, spewing out all sorts of heat-trapping gases. Either way, things start to heat up, and that's where those oceans come in.
Okay, I'm seeing where this is going. Those oceans start to evaporate.
Exactly. And when that water vapor goes up into the atmosphere, well, it's not just hanging out doing nothing.
It's making things even hotter, right? Because water vapor is a greenhouse gas.
Bingo. It's like wrapping Venus in a giant, thick blanket. So you've got this vicious cycle going on, more heat, more evaporation, even more heat trapped, and things just spiral out of control from there.
That's, not great. And that's what we call a runaway greenhouse effect.
You got it. It's a stark reminder that planets, they're not static, they change over time, and sometimes those changes can be pretty dramatic. I mean, for all we know, if things had gone a bit differently, maybe Venus would be the one teeming with life, and we'd be the ones dealing with a runaway greenhouse effect.
Okay, that is a thought. And it makes you appreciate our own planet's, stability a little bit more. But even though Venus went through this dramatic transformation, it sounds like it's still a pretty happening place, geologically speaking, at least. I mean, those Wikipedia articles you sent over were talking about some pretty impressive features.
Oh, absolutely. Venus is a testament to the power of geological forces. Well, we're talking volcanic plains that stretch for hundreds of miles, towering mountains, and these massive highlands, bigger than any continent here on Earth. It's really quite something.
Yeah, I was reading about Ishtar Terra and Aphrodite Terra. I mean, the
Right.
scale of those things, just mind-boggling.
Right, and we have the Magellan spacecraft to thank for that. It used radar to see through those thick clouds and map the surface in incredible detail.
So even though we can't see the surface with our own eyes, we have this incredibly detailed picture of it thanks to Magellan. That's
It
amazing.
was a game changer, really. Magellan showed us the true extent of Venus's volcanic past, vast lava flows, volcanic domes, and these strange pancake-shaped volcanoes that we really don't see anywhere else.
Okay, those pancake-dome volcanoes, those sound too strange to be real. What's the story with this? How do they even form?
Well, imagine you've got this incredibly thick, viscous lava, right? But it's trying to erupt under this incredibly dense, heavy atmosphere. All that pressure just forces the lava to spread out instead of forming a towering cone like we see on Earth. It's like trying to squeeze a giant cosmic pancake batter dispenser.
So you get these flat-topped volcanoes instead of the classic cone shapes. It's amazing how different geological processes can be on other planets.
Right. And we're still just scratching the surface, so to speak. Magellan also found evidence of these massive shield volcanoes, some of which might still be active today.
Wait, active volcanoes? You're telling me Venus could still be volcanically active right now? How do we even know that?
There have been these fluctuations in the sulfur dioxide levels in Venus's atmosphere, and that could be a sign of eruptions. It's still a bit of a mystery, but it's definitely a possibility.
Okay, so we've got the super dense atmosphere, scorching temperatures, and volcanoes that might still be erupting. What's the weather like on this planet? Because I have to imagine it's not exactly a gentle breeze.
You think. The atmosphere of Venus is a wild place, and to understand why, we need to talk about its rotation, or rather, its extremely slow rotation.
Wait a minute, Venus rotates slowly? How slowly are we talking?
So slowly that a day on Venus is actually longer than its year.
No, that's just messing with me. A day longer than a year, come on.
It's true. And not only that, but Venus also rotates in the opposite direction to Earth. We call that retrograde rotation.
Retrograde rotation, a day longer than a year. Man, Venus just likes to keep things interesting, but how does that affect the weather?
Where you put that slow retrograde rotation together with this super dense atmosphere, and you get some truly bizarre weather patterns. For one thing, the wind speeds on Venus are no joke. We're talking hundreds of kilometers per hour, faster than most hurricanes on Earth.
Okay, so imagine those winds whipping around those pancake-dome volcanoes. It's gotta be like something out of a sci-fi movie.
It's pretty wild. And then there's what we observed at the South Pole, these massive double vortices.
Double vortices, what in the world is a double vortex?
Picture two gigantic hurricanes swirling in opposite directions, right on top of each other.
Okay, you've officially lost me. How does something like that even happen?
Honestly, we're still trying to figure that out. Venus is full of these head-scratching mysteries, and the more we learn, the more questions we seem to have. But one thing's for sure, Venus is anything but boring.
You got that right. It's definitely not the kind of place you want to get lost in a storm. It's amazing to think that we've got this whole other planet right next door, and it's still got so many secrets.
That's what makes it so fascinating, right? Every time we think we're getting a handle on things, Venus throws us another curveball.
It's like it's daring us to figure it out. And speaking of figuring things out, we've talked about the surface, we've talked about the weather, but there's this whole other layer to Venus, literally, that we haven't even touched on yet, those clouds.
Ah, yes, those enigmatic clouds.
Yeah.
They're not just there for show. They're practically a world unto themselves.
Exactly. And a world that might just harbor life. I mean, that whole phosphine detection really threw a wrench in things.
Yeah, that caused quite a stir in the scientific community. Phosphine, you see, is often associated with microbial life here on Earth. So finding it in Venus's atmosphere, Well, it really got people talking.
I can imagine. It's not every day you find hints of possible alien life, even if it's just microbes.
Right. And the thing is, the environment in those clouds, it's incredibly harsh, incredibly acidic, not exactly the kind of place you'd expect to find anything living.
So if there is something living there, it would have to be incredibly tough, incredibly adapted.
Exactly. It would really push the boundaries of what we consider habitable, which is, part of what makes this whole thing so exciting. Of course, not everyone's convinced. There are other explanations for the phosphine, maybe some kind of geological process we don't fully understand, or even just issues with the observations themselves.
So the mystery continues. But it sounds like we need more data to really get to the bottom of this.
Absolutely. We need more missions, more observations to really unravel what's going on in those clouds. And the good news is those missions are on the horizon. Da Vinci, for example, that's one to watch. It's going to be taking a deep dive, literally right through Venus's atmosphere, measuring its composition, taking pictures. It's going to be incredible.
Okay, now I'm even more excited about the future of Venus exploration. It feels like we're on the verge of some major breakthroughs.
I think so too. And the best part is, this is just the beginning. Every new discovery opens up a whole new set of questions, and that's what makes exploring our solar system so endlessly fascinating.
It's true. There's always something new to discover. Before we wrap up, any final thoughts for our listeners who, like us, are completely captivated by Venus?
How about this? We've talked about the possibility of microbial life in Venus's clouds, but what about its past? What if, at some point, billions of years ago, Venus had its own moon?
A moon, like Earth's moon. I've never even considered that.
Most people haven't. But think about it. What if Venus did have a moon and something happened to it? What could have possibly happened to a moon-sized object in our solar system?
It's a question I'd never even thought to ask, but now I desperately need an answer. We've covered so much ground in this deep dive, from scorching surfaces to swirling, potentially life-harboring clouds, to the possibility of ancient moons. It's incredible how much there is to discover, even right here in our own cosmic backyard.
It really is. And that's the beauty of science, isn't it? There's always more to learn, always more to explore. Who knows what wonders await us out there?
And to our listener, who knows, maybe you'll be the one to unravel some of those mysteries. This has been an incredible deep dive into the world of Venus, and we can't wait to see where our curiosity takes us next time. Until then, keep exploring.